program is intended to give the viewers a general understanding of the presentation of Montessori materials to children. It is not intended as a course in the Montessori philosophy or background of each material. The materials of themselves do not constitute the Montessori method. Those trained in the Montessori philosophy understand that the materials are secondary to the principle of developing independence through freedom of choice. It is this brain-driven developmental urge which the adult is trained to observe and support. With that training, the adult links the child to the self-teaching materials which match her interest. A complete knowledge of the materials and their function requires a certified Montessori education program, which traditionally requires at least a year of training and internship. The materials are presented in a carefully planned order that provides the child with new challenges when he is ready to take them on. A new material may provide new small muscle challenges or more abstract thinking. The teacher's role is to observe when the child is ready and introduce new work accordingly. Montessori materials are usually presented at a child-sized table or on the floor. Floor materials require a rug to differentiate the material from the surrounding space and to provide an orderly environment in which to work. The emphasis in a Montessori classroom is the love of learning. It is not important that a child learn faster than his classmates. Every child works at his own pace, moving on when he is ready. When a child is working, he is rarely interrupted. By giving the child control of his own work, Montessori makes learning a powerful experience that keeps the child motivated. Montessori children love learning because it is fun, it is beautiful, it is age-appropriate, and is designed to meet their needs. Math vocabulary can be taught with what Montessorians call the three-period lesson. In this case, she will demonstrate a three-period lesson on geometric solids. In the first step or period, the teacher identifies each solid as she lays it out. This is the ovoid. This is the cylinder. This is the cube. The second step of the three-period lesson is to ask the child to show you the solid when asked. Where is the ovoid? The teacher asks. The child points to the ovoid. Show me the cylinder. The child points to the cylinder. Show me the cube. The teacher mixes up the solids and practices again with the child, using the second step in the three-period lesson. Finally, in the third period or step, the teacher asks the child, "What is this?" And the child will respond, "This is the cube," verifying that the child has absorbed the information presented. The three-period lesson is frequently used to make learning new words fun. The teacher is able to observe the child and move ahead to the next step when he is ready. The concept of comparative length is introduced with the red rods materials in the sensorial curriculum. The red and blue rods, or number rods, initiate the mathematics materials. 10 rods alternate in color to indicate units from 1 to 10. This material increases the level of abstraction by identifying length in units 1 to 10. Each rod is laid down slowly in descending order. The first rod is 1. The child says 1. The second rod has 2 units. The child counts 1, 2, and so on. The rods provide a visual and tactile representation of comparative length and the first sense of the meaning of numbers. Like most Montessori materials, the number rods have a control of error that allows the child to identify a mistake and correct it without the assistance of the teacher. In this case, you can see that the rod is out of place, and the child can correct it as needed. Young children love repetition and will repeat a material often until they are satisfied that they mastered the concepts. The sandpaper numbers provide the child with an opportunity to feel the number as he begins the visual process of recognizing the numeral and the physical process of writing it. Like all Montessori materials, the sandpaper numbers are beautiful and stimulate the child's senses to maximize learning. The teacher sits on the child's dominant side when presenting a lesson. If the child is right-handed, the teacher sits to his right to ensure that the child's perception of the lesson is optimized. The teacher takes each number out of the box and traces it 2 or 3 times with her finger. Then she gives the child the opportunity to trace the number. After the child is familiar with the number, the teacher repeats the process and says the number aloud. Each new material provides a new level of abstraction. The next step is to combine the number rods and number cards. The child lays out the rods and correctly labels each rod with the appropriate number. The concrete representation of the numbers 1 to 10 are now represented by the abstract symbol learned with the sandpaper numbers. The spindle boxes introduce the concept of 0 to the child for the first time. It also demonstrates all the digits used in the base 10 system of numbers. The teacher indicates that no spindles go into the 0 box, that 1 goes into the 1, 2 into the 2, and so forth. Each number is counted out in the hand to provide a tactile and visual sense of the number. At the conclusion of the counting process, the child bundles the spindles together with a string or rubber band to emphasize the quantity represented by each number as a set. Ten individual numbers or cards accompanied by small discs give the child the opportunity to count out the discs to match each number. The teacher lays out the material for the child as shown here. The concept of odd and even is introduced with a demonstration of how the odd number of discs block the finger, while the even number allows it to pass. At the end, the even numbers can be counted at the top, and the odd numbers can be counted at the bottom. The layout of the discs and the fact that there are a precise number of discs ensures that the child will discover and correct an error in his layout should one occur. The teacher introduces the golden beads by laying them out on a rug. When a child works on the floor, a rug is used to focus the child's attention on the work and to provide a sense of order. The golden beads provide 9 single unit beads, 9 10-bead bars, 900 bead squares, and 1,000 bead cube. The golden beads provide an opportunity to feel how 1 compares to 10, 100, and 1,000. They also begin the process of recognizing squaring and cubing a number. For example, a square can be made with 10 tens and a cube can be constructed with 10 hundreds. Number cards are added to the golden beads to begin mathematical operations. The number cards are color-coded with the units green, the tens blue, the hundreds red, and the thousands green again. The teacher represents a number with golden beads and the child goes to the number card layout and picks up the appropriate number card for each bead set. The child chooses 1 card at a time to focus on the particular order of number. In this case, the teacher has chosen 3 units, 2 tens, 3 hundreds, and 1,000. Once the child has brought back all the appropriate cards, the teacher stacks them so that they are all aligned with the 1,000 card, and then slides them down to reveal the answer. This action is called the magic slide and gives the child a sense of wonder about the creation of a complex number. The cards have formed 1,323. Here we see the layout for a golden bead addition lesson. There are 3 trays, 1 for each of the add-ins and 1 for the sum. there is a store of beads for the students to draw upon. The store is normally kept on the shelf during this presentation. There are large and small number cards, with the small cards being used for the add-ins and the large cards for the sum. Unlike most other materials, Golden Bead addition is only done with the teacher involved. Usually 2 students participate, each taking responsibility for a tray of beads representing an add-in. The teacher lays out the cards for the students to match with golden beads from the store. Here, the first student has brought back 2 units, 4 tens, 3 hundreds, and 1,000. The second student brings back 9 units, 7 tens, 5 hundreds, and 2 thousands. Let's listen as the teacher describes how she completes the presentation.
So then, in this big, massive upheaval, they just take it all, just everywhere. So someone may think, what are they doing? What are they doing? Putting it all in there. I use 2 hands, massive upheaval, and then we fix it. That makes it a little bit of interest. Okay, and then here we have to find out now what we have. So the children will take turns and they'll actually do the counting themselves, always starting with the units. So we have 1 unit, 2 units, 3 units, 4 units, 5 units, 6 units, 7 units, 8 units, 9 units, 10 units. Stop. When you have 10 units, that's the same as the children usually can reply 110. So we'll leave this one here. The child will use their tray to take this to the shelf. And it has our store in it, where our storage is. And they're going to trade it in, exchange it. 10 units, same as 110. And we'll bring them back. It's on our pile. And we have 1 unit left. We're going to get that from the large decimal cards. We started with small ones because we each had an individual small number. Now we're going to go to large decimal cards because we put together 2 small numbers, and now we're going to create a large one. So the child would go to the large decimal cards and get the 1 unit for it. And then we take a turn, and then the other child may count the tens. So here we have our answer. We go ahead, do the magic slide. Put it over here. And then this is what we get into the explanation part of what we actually did. So we're going to take the first child's number. I'm going to say that we have 1,304 tenths and 2 units. And we took 2,000s, 500s, 7 tens, and 9 units. We put them together and we got one large number, which was 3,000s, 900s, 2 tens, and 1 unit. When you take a bunch of small numbers and put them together and get one large number, that's what we call addition.
In this case, 3 children participate in golden bead subtraction. The teacher has a very large number which each of the students will subtract their number from. The teacher's tray contains 9,999 beads and the corresponding number represented in large number cards. The teacher asks the first student how many units he needs. He needs 3 units, so she gives him 3 units. How many tens, she asks. I need 3 tens, the child responds, continuing until the child has enough golden beads to match his number cards. The child is asked to verify that the correct number of beads have been provided. Finally, the teacher does the magic slide to reveal the child's number. The teacher then counts the remaining golden beads on her tray and lays them out to show that after the student's number has been subtracted from 9,999, the remainder is 8,566. The teacher turns over the original cards to indicate that that number is no longer relevant and proceeds to the next student, repeating the process. With golden bead division, the teacher again has laid out the work for 3 students to participate. The number 3,693 will be divided by 3. She has chosen the number so that there will be no remainder as a beginning lesson. Starting with the thousands, the teacher divides them between the students. 1,000 per student. Moving on to the hundreds, she divides the hundreds, resulting in 2 hundreds per student. Each student receives 3 tens and 1 unit. The children obtain number cards to match their golden beads, and the teacher performs a magic slide to reveal that all 3 have the same number. Finally, she lays out the original number on the rug and says 3,693 divided by 3 people is 1,231. The teacher concludes, when you take a large number and divide it, you get a smaller number. In the stamp game, the student is given a problem by the teacher. In this case, we are doing an addition problem. The color-coded stamps are laid out to represent each number to be added. Like the number cards, the units are green, the tens are blue, the hundreds are red, and the thousands are green, representing units of thousands. The child lays out the stamps to represent the 2 add-ins. In this case, he has 1,426 plus 2,313. In this problem, no carrying is required, but the stamps can be traded in for the next larger stamp if necessary. The stamps are combined and the child records her number. Once the student is comfortable with the stamp game, she can generate her own problems to solve. The dot game gives the child the opportunity to add many numbers at a time. In this case, we have 6 numbers, all over 1,000, to add. Starting with the first number, the child places dots in each category 1 number at a time. The first number is 3,142, so the child places 2 dots in the unit section, 4 dots in the tens section, 1 dot in the hundreds section, and 3 dots in the thousands section. The process is repeated with the remaining 5 add-ins. Once each number is represented by dots, we are ready to add. We notice that we have a complete row of 10 dots, so we cross out the row and place a dot at the bottom of the sheet to represent 1 10 to carry over to the next sheet. We have 2 complete rows with no dots remaining, so the units column gets a 0 placed at the bottom. Next, we write a 2 below the tens column and add 2 dots from the bottom of the units column and proceed with each column in the same manner until we have the solution, 15,620. The teen board consists of number cards and beads. The child will use up to 9 10 bars and a new set of bead bars with 1 to 9 beads for the units place. These beads are color-coded. The child begins with the tens in place and inserts a 1 in the first slot to form the number 11. He then places a 10-bead chain and a unit bead to represent 11. This continues until the child reaches 19. The number 19 is formed with a 10-bar and a 9-bar. The 100 board provides a 10 by 10 square grid for counting practice. The child places the appropriate tile in each square, reinforcing the concept of 9 as the greatest number of units, and then changing to 110 greater, until all 100 squares are filled. Every 3 to 6 classroom has a bead cabinet with chains of beads representing the squares and cubes of numbers 1 through 10. Here the teacher demonstrates the 4 chain. She has counted each segment, labeling the beads with numbers. The 4 chain can be folded to form the square of 4, or 16. The 4 square beads serve as a control of error for the student. The 4 cube chain is laid out by the student. Each segment is counted and labeled as you see here. The 4 cube chain can be folded to form 4 squares, which stack to form the cube of 4, or 64. Again, the 4 square beads and the 4 cube beads provide the student with a control of error. These exercises build a visual and tactile sense of the meaning of numbers and the function of squaring and cubing. Color-coded bead bars representing each number from 1 to 10 are used for the addition snake game. The child can choose any combination of numbers to add. In this case, she has chosen 6 plus 3 plus 5 plus 4 plus 2 plus 1. Consistent color coding gives the child an additional clue in identifying the number of beads on each chain. Let's watch as the teacher demonstrates this material.
1, 2, 3, 4, 5, 6, 7, 8. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. I have 1 here. Then 1, 2. So I have 10, 20, 21, 22. My snake was 22.
The addition chart includes a container with all the addition problems from 1 plus 1 to 10 plus 10. The child draws an equation from the container and lays it on the platform provided. Next, she copies the number on a small sheet of paper. Using her fingers, the child places a finger on each number on the red and blue rows to represent the addends. Sliding the fingers together along the matrix, the child discovers the answer. Repetition of this activity leads to memorization of the addition table. Upon completion of the problems, the child can check her answers with a control chart. The use of a control chart enables the child to be totally independent in doing this work. In the negative snake game, bead bars are laid out to represent positive and negative numbers. The negative numbers are all color-coded gray. The child counts the beads until she reaches a total of 10 and exchanges the beads for a 10 bar. If a few beads are left over, those beads are replaced by the appropriate number bar and the counting continues. If a gray bar is encountered, it is placed parallel along the accumulated beads and the same counting process is done, except these beads are removed from the chain. This process continues until a positive or negative number of beads remains. When the process is complete, the remaining beads are laid out to represent the answer. In the subtraction strip board, a matrix of squares 19 across are used to practice subtraction tables. The child chooses a table. In this case, the table of 14 is chosen. The brown wooden bar is used to block the numbers from 15 to 19 that will not be used. The blue bars represent the numbers 1 through 9. The child places each bar on the board to reveal the answer to the equation. Placing the 9 bar on the board creates the equation 14 minus 9 equals 5. "14 minus 8 equals 6. She continues until the table of 14 is completed. The multiplication board is used to memorize the multiplication tables. The table to be practiced is represented by a number placed in a slot in the board. In this case, we are going to practice the table of 6. 6 beads are laid out in column 1 to represent 6 times 1. The answer 6 is placed on the table. The 6 times 2 equation is represented by moving the red disc to the second column. 6 beads are added, and then all the beads are counted. 6 times 2 is 12. The process continues until the table of 6 is completed. The child can choose to move on to another multiplication table or choose another type of work in the classroom. The multiplication finger chart works in the same way as the addition finger chart. The child can choose an equation from the container. By sliding her fingers from the red and blue columns, she can discover the answer to the equation. Repetition of this work and the multiplication board will result in the memorization of the multiplication tables. The unit division board is used to practice division problems. In this case, the teacher is going to divide the number 14 by 9. The divisor is represented at the top of the board by 9 green Skittles. The dividend is represented by 14 beads counted out into a cup and then distributed 1 to each Skittle across the board. Each bead is laid out in a row to match the Skittles. After a row is complete, another is started until the beads are exhausted. There is one row with 5 beads remaining. The answer is 1 with a remainder of 5. The division finger chart enables the child to practice her division tables. A problem is chosen and laid on the platform. In this case, the equation is 45 divided by 9. Sliding the fingers on the chart reveals the answer 5. The small bead frame provides an abacus-like tool for doing math. Here, the teacher has chosen to add 3,421 and 5,324. She writes out the equation and begins adding the beads, starting with the units. If the category exceeds 10, a bead in the next row is moved and the entire unit row is moved back to the left side, and the count continues until the units are all counted. Then she moves on with the tens, hundreds, and thousands to find the answer to the equation. Once the small bead frame is mastered, the child can move on to the large bead frame, with categories up to the millions. The metal inset fractions allow the child to visually discover how various fractions compare to each other. In this case, we look at the fraction of 1/2. Do 2/3 add up to 1/2? No. Do 2/4 add up to 1/2? Yes. Do 3/5 add up to 1/2? No. How about 3/6? Yes. This process can be continued with all the metal inset fractions to compare a variety of fractional relationships.